Many people think black holes are doors. They imagine giant cosmic doorways. These are tunnels leading to another place, maybe another time, or even a whole new universe. This is a powerful and exciting image. It has filled our science fiction stories and our dreams for decades. It makes us wonder what lies beyond our own world. But as we look at the stars with our telescopes and our equations, we find a different story. The reality of a black hole is even more fascinating than the myth, and it teaches us about the very fabric of the cosmos. A black hole is a place in space. It is a region where gravity is incredibly strong. Imagine something so heavy, packed into such a small space that its pull becomes overwhelming. The gravity is so intense that nothing can move fast enough to escape it. Not even light, the fastest thing in the universe, can break free. This is why we call them black holes. They don't shine or reflect light. They are dark voids against the backdrop of the stars. Near this cosmic giant, the rules of our everyday world bend and twist. Time itself can slow down, and space gets warped. The idea of a door is a simple way to think about a complex thing. It feels familiar. We open doors to go from one room to another. So, a black hole as a door to another universe feels like a natural step. It speaks to our human desire for exploration and discovery. We want to find new frontiers and see what's on the other side. This is why the myth is so popular. It captures our imagination and our sense of adventure. The great scientist Stephen Hawking gave us a revolutionary idea. He looked at the strange physics near the edge of a black hole. He realized that black holes are not completely black. They are not perfect prisons. Over a very, very long time, they can actually give something back to the universe. They can leak. This slow leak is not a flood of matter or a spaceship flying out. It is a faint glow of tiny particles. This amazing concept is called Hawking radiation. It completely changed how we think about these cosmic giants, showing us that even the darkest objects in the universe have a way of shining. So where does this leak come from? It does not come from inside the black hole. Nothing can get out from inside. Instead, it comes from the empty space right at the black hole's edge. This edge is called the event horizon. In the quantum world, empty space is not really empty. It is buzzing with energy. Tiny pairs of particles pop into existence for a split second. Then they usually come back together and disappear. They are like quick sparks in the dark. These are known as virtual particle pairs. They are a normal part of how the universe works at the smallest scales. Hawking's big idea was about what happens when these particle pairs appear right at the event horizon. Sometimes one particle in the pair falls into the black hole. The other particle is left all alone. It has no partner to disappear with. So, it is free to fly away into space. To an observer far away, it looks like the black hole has just spit out a particle. This escaping particle carries energy away from the black hole. It's like the black hole is slowly evaporating, losing a tiny bit of its mass with every particle that escapes its gravitational clutches. This process is incredibly slow for the big black holes we see in space. A black hole the size of our sun would take longer than the current age of the universe to evaporate. But the idea itself is huge. It connects the world of gravity and black holes with the weird rules of quantum mechanics. It shows that black holes are not eternal. They have a life cycle. They are born from massive stars. They grow by eating matter, and eventually they can fade away into nothing. This is not a door to another world. It is a deep and beautiful law of nature at work. Now, you might hear a different story about what black holes spit out. Some people say that black holes are cosmic filters. They claim that a black hole sucks in what they call negative ions and shoots out positive ions. This idea sounds simple and scientific. It uses words we have heard before, like ion positive and negative. It creates a picture of a black hole that is cleaning up space, sorting out particles, keeping the good stuff while getting rid of the bad. This story is easy to share and sounds plausible, which is why it has spread online. But this story is a myth. It is a misunderstanding of the real physics. The idea of positive and negative ions belongs to chemistry and electricity. An ion is an atom that has lost an electron or gained an electron. This gives it a positive electric charge or negative electric charge. For example, the salt in your kitchen is made of sodium and chloride ions. This is a very different concept from what happens near a black hole. The particles involved in Hawking radiation are not everyday ions. They are fundamental particles, like photons or neutrinos, created from the energy of space itself. The myth mixes up two completely different scientific ideas. It takes the concept of ions from chemistry and incorrectly applies it to the physics of black holes. The real process described by Stephen Hawking is about particle-antiparticle pairs, not positive and negative ions. These pairs are a matter particle and its antimatter twin. They are created from pure energy in the quantum vacuum. When one falls in, the other escapes. The escaping particle can be a particle or an antiparticle. It has nothing to do with atoms losing or gaining electrons. The ion story is a fiction. It is important to separate the myth from the reality. While the ion story might sound appealing, it does not match what our best scientific theories tell us. Science is a process of testing ideas against evidence. The idea of Hawking radiation is built on decades of work in both gravity and quantum physics. It is a well-tested and accepted theory. The story about ions, on the other hand, has no basis in the physics of black holes. It is a good example of how scientific terms can be misused to create a story that sounds real, but is ultimately false. Even though the ion story is a myth, it touches on a very important and real idea. The myth says, "Nothing is lost. Everything is changed." This phrase is a powerful way to think about one of the most fundamental rules of the universe. In physics, we have a law called the conservation of mass energy. It means that you cannot create or destroy mass or energy, you can only change them from one form to another. A black hole is a perfect example of this law in action. It is a place of incredible transformation, where matter and energy undergo extreme changes. When matter falls into a black hole, it does not just disappear from the universe. Its mass and energy are added to the black hole. The black hole gets heavier. Its gravitational pull gets a little bit stronger. Think of it like adding a drop of water to a giant bucket. The drop is still there. It has just become part of the larger whole. The energy of the falling matter can also be converted into other forms just before it crosses the edge. Gas dust spiral into a black hole. They get incredibly hot and bright, releasing huge amounts of light and X-rays that we can see with our telescopes. This is what makes black holes visible to us. We cannot see the black hole itself, but we can see the fireworks happening around it. The bright disk of superheated material swirling around the black hole is called an accretion disk. It shines more brightly than entire galaxies. Sometimes a black hole also shoots out massive jets of particles. These jets travel at nearly the speed of light and reach thousands of light years. They're some of the most energetic and spectacular events in the cosmos. All this light and energy comes from the matter that is being changed as it falls toward the black hole. And what about the energy that leaves? The escaping particle from Hawking radiation carries energy away. This energy is not created from nothing. It is borrowed from the black hole's own gravitational field. As a result, the black hole's mass slowly goes down. So the law is followed. Energy is conserved. It is just moved around and changed from one form to another. Mass goes in, the black hole grows. Radiation comes out, the black hole shrinks. It is a cosmic dance of energy and mass, governed by the laws of physics on the grandest possible scale. So, what is a black hole? It is not a magical door to another dimension. It is not a cosmic filter sorting out ions. The reality is far more subtle and profound. A black hole is a place where matter is crushed to an unimaginable density by its own gravity. It is a region of space where time is warped and reality is warped. It is an object that can slowly, over eons, radiate its own mass away back into the universe as a faint glow of particles. The simple truth, discovered through careful science and mathematics, is often more wondrous than any myth we can invent. The journey to understand black holes is a perfect example of how science works. We start with observations and questions. We build ideas and theories to explain what we see. Then we test those ideas with more observations and experiments. Stephen Hawking's idea was a brilliant piece of theoretical work. Now, astronomers are searching for the evidence of his theory with powerful telescopes. They are looking for the faint signs of evaporating black holes to confirm his prediction. Every new discovery is a step forward, bringing the true nature of the cosmos into clearer focus. This quest for knowledge does not happen on its own. It requires curiosity, hard work, and support. Science is a team sport, and it needs everyone on the team. It needs thinkers, builders, and dreamers. And it needs supporters who believe in the power of discovery. When you learn about the real science of black holes and share it, you become part of that team. You help replace myths with facts. You help spread the excitement of real scientific discovery to others. Your voice matters in building a world that values evidence and reason. This is why we ask for your help. A small gift of just $1 can make a big difference. It helps fund the research. It helps build the next generation of telescopes. It helps create educational programs that bring science to everyone. With your support, we can continue to prove our ideas and push the boundaries of what we know. We can find the answers to the biggest questions about our universe. So please, share this story. And if you can, join us in this grand adventure. Let's uncover the secrets of the cosmos together.